Everyone, welcome back to my channel. Thanks for being here. Hopefully, you are learning through the experiences shared over this channel. Um, as this is could be the third or fourth videos in the playlist, and this is going to be a continuous part of the data types, especially basic data types video that we have seen. Um, now, uh, I'm going to just continue the same in this video over operators supported by Python to make to and for this particular video again you do not have any prerequisite as such. You need to have at least one working Python supported integrated development environment. I am going to use Jupyter Notebook as that of the environment. However, if you are familiar with or comfortable to work with any other IDE, please stick to that. Um, well, it is not mandatory. However, it is recommended that you do carry a pen and paper along while going through the rest of the videos too. There will be several key points, bonus points, interview questions, or important questions as per fundamentals significance will be shared. If you can mark them, they will certainly help you at the later stages to understand the higher concepts that we'll discuss. Again, this may not be true for everyone that you are watching these videos, but for most of you, and especially for those of you who do not have any programming background and learning any programming language for the first time. Well, it wasn't to discourage you, but rather to make sure you understand and carry along the good fundamentals concepts as you move forward. Now, let's jump to understand what are the operators and how many types of operators does Python support. If you are not sure what an operator means, just understand the plus operation is performed with the plus operator, right? You remember? The subtraction, to do any subtraction in mathematics we use minus sign. To do multiplication we use asterisk or x sign. To divide something we use slash. Likewise, in Python we have a set of operators. In fact, multiple categories are there that will help you to basically read through them and use them whenever required, and that is what this video is going to be, and covering them in detail. Okay, so as you see on my screen, there are 7 groups of operators in Python, starting from the common group that we always are aware of, arithmetic group or arithmetic types, comparison types, or these are also called relationship types, logical type, bitwise set of operators we have, then assignment operators group, and identity operators and membership. As said, most of you may be familiar with a lot of these terms, but in context of Python, the membership and identity operators are some new sets of operators that you would certainly and you must go through. That's recommended. In the next session, I will walk you through each of these groups and each of these types of operators, and also will take up examples to see how they work with various data types or with various operand types. Let's quickly see that. Okay, so the very first set of operators that we have, that's arithmetic operators. So arithmetic operators helps you to perform arithmetic operations. And as we know, arithmetic operations are applicable for numeric data, not for string data. If you do not know the various data types available in Python, I recommend you to watch the previous video before proceeding further, because I'm going to take examples on all these operators with respect to the data types. So you must be comfortable with the basic data types, sorry, that Python do has. So Python has integer data types, floating data types, string data types, and some more. So just watch the videos and come back. Now, continuing here, whenever you want to perform arithmetic operation, you have to go with arithmetic operators like you see on the screen. Plus symbol that is used to add two numbers, minus or hyphen what you call that is used to basically subtract a number from the other number. For float division, we have just a single slash. For double, there is something called integer division in Python. For that, you have double slash. And for multiplication, you have asterisk. For exponentiation or to raise a power, or also called power operator, you have double asterisk. And for modulo operation, you have percentage sign. Now, what is modulo? Modulo is nothing but the remainder after a division operation. If you ever want to see the remainder, you have to use modulo sign or percentage sign. Now, if you're thinking what would be that scenario, you would need a remainder information. To give an example, to check if a number is an even number or odd number, right? So if you remember, the definition of an even number is that when you divide it by 2, the remainder should be 0. So here the remainder is informative information. So your model operator will help you to get that remainder, right? Um, so I have got a set of few examples just to see how this operation works, how this operator works with various type of data. So very first data that you see, that's on two different integers. My number one is again 40, number two is 30, and I'm performing all these arithmetic operations on them. Can you guess what will be the output for each of these expressions? You can pause the videos and you can write down your output, and then let's see if Python is giving the same output as you expected, and then we can discuss what could be the reason. Okay, so you're back after pausing the videos, and let's see the output. So for me, let's see that these are the outputs. Were you expecting the same output, and did you get the same? Well, so 40 plus 3 will be 43, which makes sense. 40 minus 3, 37 makes sense. 40 into 3, that is 120, makes sense. 40 divided by 3. Now, if you remember, I said single slash represents floating point division. In general, the normal division that we are aware of. So when you divide 40 by 3, it will end up to a non-terminating decimals, and that's what you see. But again, since Python has a limitation on the memory point of view, it cannot go on infinite to store the number. So there are some limited precision up to which Python will store your repeating floating points, decimal, or the fraction component. So it will be up to 15 decimal places, and that's what you see. So after the 15th, it has rounded off, but ideally it should not. In ideal world, it does not happen, right? Then now, when you are dividing 40 by 3 with a double slash symbol, which represents your integer division, so what is happening? You got everything after truncating the components after decimal. So basically an integer part of it. So whenever you need just an integer value after some division operation, you are not worried about the fraction component of it. That means you are ignoring the remainder part of it. You are just interested on the quotient of the division. You can go ahead with the double slash. And that's the use of double slash. Um, you are wondering where can I use it? Um, you know, um, if you understand this technically, whenever you have to split a multi-digit number and split into its digits, or you have to reverse that a number, you will have to basically slice down the number, and there where you need double slash. You can try that out today, it will be useful for you. Then we have double asterisk, which acts as a power operator. So this is as good as saying 40 to the power 3, 40 cube, and that should give you 64,000, right? Then next in the sequence is modulo operator. That is when you divide 40 by 3, what is the remainder that you can expect, and which will be 1. So that's the reason we got 1. Is that clear? So this is how your arithmetic operators works when both of your operands are of numeric type. By numeric type, I mean either integer or floating point or complex number. Although we are not dealing here much with complex number, for the region, the data that you'll be mostly dealing in real time, and especially at the industry level, that never goes as a complex number. Until you are in a research field, then there where the complex number has more significance. Let's see what happens when you perform these operators. Can you work with arithmetic operators for the string data? As I said, text data or string types are not recommended on for those types of data in real time too. We don't do addition and subtraction. We don't say, okay, we I have two names, can I add them? No, we try to compare them. So where the string data are meant to be more for comparison type, all right, not for addition or arithmetic operation. But there are some exception, not in the arithmetic operation, rather exception for plus symbol and asterisk symbol, or these two operators. These two operators works with the string data too, but they do not give you the same result as that of the arithmetic operation. Rather, your plus operator acts as a concatenation operator when you have both the operands as of string type. So this is of a string type. Can you see that? This is a string type, and so is the first one. So whenever you call a plus operator over two string data, that they will be concatenated and you will get a result like 2 3. 2 plus 3 is nothing but 23 here, this way, right? And your asterisk operator acts as a replicator operator. It performs replication operation. Whenever you multiply it, um, you use it between an integer and a string data. So here my n1 is a string which is 2, and then I'm trying to replicate that 3 times. The simplest way I can do is using asterisk operator, as you see. What will happen if I call 6? So my 2 will be repeated 6 times. So these are the two exceptional behaviors of plus and asterisk operators on string data. But again, this is not applicable for other arithmetic operators. Only the exception goes with these two operators. Hopefully, you are clear with the arithmetic operator sets and their behavior. Now, let's see the next set of operators called comparison operators, or also called relationship operators. As the name suggests, the purpose of these operators are to compare the value of two different operands. Now, these operands can be either numeric type or they can be string type as well. So, comparison operator works with both numeric and string type in Python. And the list of the comparison operators that you see on my screen are the one here. These are the 6 comparison operators. You must be familiar with the symbols, but again, if in case if you're not, let me highlight that. So this is called equal to operator. This basically returns you a boolean true whenever the two values are equal. Not equal to operator, opposite of the above one. Less than operator, less than equal to operator, greater than operator, and greater than or equal to operator. You have to clearly understand it is or. That means even if one of the condition is true, the result should be true. Now, comparison operators always gives answer in real time. Like if I'm comparing some two things like is 5 greater than 4, the answer will be in terms of yes or no, or true or false. Likewise, in Python, the to answer this comparison, the operation using comparison operators will return you a bool value, either true or false. Remember, bool values are keywords, And these are exceptional keywords which have some letters of it in uppercase. Otherwise, all other keywords have are all in lowercase font. Now, so what is the purpose of comparison operators are to compare two operands. Now, this is important. Can you compare at a time 3, 4, 5 operands? Not at all. Max 2 operands with one comparison operator. So now, to give you an example, we have got few examples on numeric data and then few on string data. What do you think? What will you get when you execute these codes line by line? What will be your answer for the second, third, fifth, sixth, eighth, and ninth line? You can again pause this video and write down your answer, and then you can come back and check. All right, let's check the answer. So here are the answers for the first set of examples. So is 5 equals to 5? That's true. It is true. That's why you got a true. Is 5 not equal to 5? Which is false. That's why you get a false. Is 5 greater than 5? Which is again false. 5 is not greater than 5. Is 5 greater than or equal to 4? Well, 5 is certainly not equal to 4. However, 5 is greater than 4. So since one of the conditions is true, the answer will be true. And then the eighth line says, is 5 less than 9? Which is true. And that's why you see a true. And the ninth line says, is 7 less than or equal to 9? Well, 7 is less than 9, but it is not equal to 9. But since one of the condition is true, the final result is true. Clear? Let's see how it works on your string data. Right. So the first statement says, is ABC, string ABC, equal to string ABC? And if you really see, yes, they are equal. Even from Python's perspective, of course, they are value-wise equal as well as case-wise they are equal. And there are equal number of characters, equal number, and the order is also same. That's why they are equal. So that's the reason we get a true. In the second case, again, it's saying is ABC equal to ABC and it returns a false. And I am sure you already know the reason. Since Python is a case sensitive language, capital A and lowercase a both are treated differently to be different. The third question says, is ABC equal to ABC? Now, here in this scenario, if you see, first I am doing a typecasting of my uppercase ABC to a lowercase ABC, and then I am doing a comparison with a lowercase ABC. And hence, both of them will be true eventually, and that's why the answer is true. The last line says, is ABC same as BCD? Well, that's not true because they represents two different string and that's why they are not true, right? So that's all about the comparison operator. Hopefully these examples covers of each combination, but feel free to take up your numbers, try out and see how results will vary. Try to understand your result before jumping to any conclusion. Let's see the next set of operators that's called logical operators. These are very important operators in order to combine many comparison statements or many comparison expressions. As I said before a few minutes back, you cannot compare more than two operands with a single comparison operator. So whatever if I have to do multiple comparisons and I need the final result out of a multiple comparisons. How can I achieve that? So there where your logical operators helps you to do that combining of multiple expressions. For example, let's say if somebody you have let's say a data set that represents a bank employees data and somebody says, okay, look, I want to check if the age of an employee is greater than some threshold. You can do that with simply with some assignment operator, sorry, your comparison operator like equal to. So you can just write a statement, each age equal to some value. But now I want to check for two condition. I also want to check if the person has, or if the employee has an age greater than some value, and does the employee name starts from some value. Now there are two conditions. Separately they can be true, but together they need not be true. All right, or any combination. So whenever you have to combine multiple comparison expressions, right? When I say expressions, that's nothing but a combination of your combination of operands and operators. So whenever you want to combine the result of multiple comparison expressions, there where your logical operators will help you to do that. Now the question can be, how do you want to combine them? When, for example, I can say, look, I want something to be validated to be true only when both the all the conditions are true. But some of you can say, no, fine, even if one condition is validated, I'm okay to go with. So when you want everything to be considered, you can use and operator. You want the final results to be true only when all conditions are met, then you can use final and operator. If you are okay to go along even if one condition is met, then you can use or operator between those expressions. And if you are not if you want to just change the whatever result is, you can use not operator. Let's take with an example, you'll be more clear. Before that, and or operator, this two works with two operands at any point of time. You need to have two operands between them. Of course the result of those operands, or those operands, should be eventually as a boolean value, or that can be just two single value, or they can be a complex expression when I say this operands. To give you an example, I can say 5 and 5, that is also fine. But I can also say true and true, sorry, just ignore the case and all. Or I can also say, so now this is operand 1 here. If you see, this is operand 2, likewise operand 1, operand 2. This is an AND operator. But I can also have this way. Is 5 greater than something, let's say 0, and 6 less than 7? Right? Now in the third scenario, my operand is expression itself. It has to have some um, comparison operators. Yes, or I can also make it a little more complex. I can say, okay, um, let's say 6 is less than equal to 5, and one more and I can have, and this two together. Now this is a single operand for this and. This is an operand for this and, but together they have two operands. You see? So you, whatever may be the case, you have to make sure you write your expression correctly such that for any given logical operators, there should be eventually two operands. And especially for and or, that's not applicable for not. Not works with a single operand. We'll take one example in some couple of seconds. But and works with a single operand. That's what you have to be careful. In terms of expression evaluation, after the expression is evaluated, what will it answer? It will answer in terms of true and false. Again, if you really ever get confused about the and working and or working, they have a truth table. For your reference, here are the truth table. You can refer them always, or you can also get them on Google, anywhere. Assuming that we have two operands, and of course eventually your operands has to evaluate in terms of boolean value for your and logical operators to work with. So I'm assuming my operand evaluated, first operand evaluated to be true, and second also evaluated to be true. In that case your and will give true. So and gives true only when both the operands are true, or both the operands evaluates to be true. If either one of them goes false, like here if you see, this is false, this is false, and here both are false. Whenever either of them goes false, the result will be false for AND operand. So AND operand gives true for only one condition when all the conditions are true around your AND operator, right? Now, if you look at your odd truth table, this is giving me true for all the scenario whenever I have at least one true. Here I have to both of them true, single true, single true. This goes false only for a scenario when all of them are false. And when it comes to not table, not to just reverse the original condition. If you have originally a true condition, it will return you a false. If you have a false condition, it will return you a true. So that is up to you to left which operator you want to use and what based on what result are you expecting out of the operations. Let's take up an example to quickly understand that. So here is an example I have. I have a set of expressions there in terms of Boolean, direct Boolean values, but you can also replace them with some expressions by combining your operands and comparison operators. Now, your task here is to tell me what will be the answer if I execute this block of code. You can again pause your videos, write down your answers, and then come back and check with the answers over here. So here are the answers. For the first line, which is line number 2, the answer is false, which makes sense. Since not of true, not is a not operator, not of true will be false as per truth table that you see here. Then the next one, not of true or not false. Now, how to evaluate when you have multiple such combinations? Can I evaluate randomly picking from anywhere? Or should I follow some rules? How can I understand as a beginner? How can I understand which one should I evaluate first? Should I evaluate this first or should I evaluate this first? All right. In that case, Python has something called operators precedence. Python provides a set of list of rule using which you can decide whenever you have multiple operators in an expression which needs to be evaluated first. It's similar to the Bodmas rule that we have learned during our schools for evaluating any mathematical expression or algebraic expression. Likewise, here, if I have to evaluate, the rule is very simple. You have to basically, whenever you have all the logical operators in your expression, in that case, you need to evaluate first AND operator. Well, the first precedence goes to the bracket operator, right? If there is any bracket or sub brackets, you have to first evaluate anything inside that. Innermost bracket should be evaluated first. If there are no brackets and only operators are there, in that case, you have to first evaluate AND, then you have to evaluate, sorry, my, I want to correct here. You have to first evaluate not gets the highest precedence, then comes and then lastly comes OR. Right. Okay. So, for example, if you look at this case, we have one innermost bracket. In that case, I cannot go first with this AND. Okay, sorry, not. That wouldn't be true. I have to first evaluate this bracket one. Then, now, but if you look at this bracket part, it has multiple combinations. It has AND, it has OR, it has AND. Now you have two AND, one OR. Which one should I evaluate first? Okay, so it's quite as I said, if you have and first and also or also and should get preference, but since you have two and which and should I evaluate? Then whenever you have multiple same operands operators, in that case you have to follow left to right rule. You have to first evaluate from left. Okay, so you have to first evaluate this two. In fact, let me give you with the clear cut answer that should be much clear. In this case, I have to first go ahead and evaluate this two first. So since it is an AND operator, true and false will be eventually a false. Now I'm done with this evaluation. Then now on top of this result, I have to now go with which one. So now there's the one or and AND. Of course, the precedence goes to AND. So I have to evaluate this two, and true and false will be eventually a false. So I write a false. Now I'm left with this expression again. False or false will be nothing but a false. So I evaluated it to be false. Now you are left with a single expression, not of false, which will be a true. That's the reason in the third output we have a true, right? Is that clear? Likewise, you can also evaluate the next one. Here you have multiple combinations. You have a not, you have a and you have a or. So first, what you should do, you should evaluate not expression, not of true, which will be false. Let's pull that out. Okay, so first you have to go ahead, evaluate not of true, which will be false. Then do you have and? Yes, there's an and, so that should be evaluated. So false and false will be a false. So I just replace that. Now both of them are odd. In that case, of course, the result will not vary if you go in any order, but as a good practice, it's it's important that you follow left to right precedence. So true or false will be basically a true, and true and or false is again a true. So final result is true. That's why you see a true here. Let's come to the last expression that says, okay, so now again you have to look where you have not operator first. In this scenario, we have two not operator, one and two. So again, whenever you have multiple occurrences of the same operator, in that case, left to right precedence goes. So I'm going to first evaluate this part. Not of false is true. And then I'm going to evaluate this part, which will be not of true is false. Now you are left with again a combination like this. So first you have to evaluate AND operator that says uh, true or false. Of course, false as per the truth table, not my own rule. True or false, true, and true or false, that's true. So again, this resulted out to be true. It's easier, right? Yes, if you know this rule, truth table rule for and or not operator, you just have to evaluate following the precedence, operator precedence rules that you can again Google and get it very easily. You don't have to worry much. Do not try to remember, just follow the table that you get on Google. And you can evaluate any complex expression. So now the question can be, okay, am I really going to evaluate these expressions? Is that going to be part of my job? No. But if you're implementing something and where you have to design your expression, which you want to be evaluated in certain ways, you have to write that correctly. So, in order to write that correctly, you must know how it works. And that's the reason we are doing this exercise. Let's quickly see the next set of operators. That's called bitwise operators. So, in Python, we have the following bitwise operators. Again, there are six of them called, so bitwise AND is represented by your ampersand, bitwise OR is represented with this pipe symbol, bitwise NOT is your tilted sign, and this is called XOR. And if you are familiar with binary operations, they're where the bitwise operators are used for. Then this is called left shift, mostly used for whenever you have to multiply by 2 or multiply by 2. Anything whenever you want to multiply by 2, you can just do left shift of the number. When you want to divide it by 2, you do one right shift of the number, right? So now here are the results. Just have a look. I'm just showing you. So again, bitwise operators also have these three operators called AND operator, OR operator, NOT operator. How does it work? Again, the The main functionality of these operators are to combine multiple expressions, and they work similar way. They have the similar truth table as that of the logical operators. So you have to follow the same truth table, which is not repeated. You can see the previous slide, and to get the screenshot of the truth table, you have to use the same truth table to evaluate the answer. So in binary world, if you're not familiar with the binary world, please Google that out and then you can talk here. So in binary operation, that I mean bit level operations, anything other than 0 is considered to be Boolean true. Anything other than not 0, a 0 is considered to be false. So whenever I say false and true, it should be giving me a false. So false is represented by, again, false. True and true will be true. So again, I'm following the same truth table. Let's see, are we getting that? Yes, we are. Okay. Okay. In a for OR operator, what it says, false or true, it should be true. True or true, true. Both of them should be true. Here is a not. So what we are saying, as I said, a 0 represents your false, and not of 0 will be true. Okay. XOR operations, it's not that important and we may hardly use them. Again, this sort of operators, because when it comes to dividing by 2 or multiplying by 2, you already know arithmetic operators. So you must be wondering, why should I even learn about this bitwise operators, which look so weird? The thing is, the advantage of working with bitwise operators is that they are working at a bit level, and any operations at a bit levels are considered to be faster. Again, you may not be able to quantify that fastness here, but that comes in terms of big application. Whenever you are designing, developing any big application, if you can save time over multiple computations of dividing by 2 or multiplying by 2, if you use arithmetic operators for that, and if you use a bitwise operators, there will be way difference in time taken. Bitwise operators are faster since they work at a binary level. So that's the reason, in case if you are preparing for any software development position or aiming to design any optimized product, you should be knowing about bitwise operators. But if you are not going to be a member of such, it is optional for you. Again, always it's good to know additional information than not knowing. Right. So XOR operations, basically, the XOR also has something similar truth table as AND, NOT, and OR. I'm leaving up to you to Google that. You'll get it if you just type XOR truth table. Let me tell you, in general, XOR basically gives a true, a Boolean true, only when all the bits, any two bits are different. If all the bits are same, XOR does not give a true value. You might be wondering what's the significance. As I said, it depends. For example, uh, let's say you have a list of numbers. Can I give you an example? Let's do that. Let's say I have a numbers like this, right? What do you see? Here you see all other numbers except one, they have pair. And I want to find a number which do not has a pair. One thing is, of course, if you are familiar with coding, you will loop through, you will do counting and find. But the same can be computed very easily, uh, and at the simplest level using XOR operation. Basically, if you perform an XOR operation on all these numbers, finally you will get one. So the properties of XOR operation says, if you have any number which is basically do not has a pair, it will return you that number. Okay, and if you have a pair of them, so 2 XOR 2 will be 0, whereas 2 XOR 1 will be something but not 0. Right. And here, if you see, this is a left shift operator, this is a right shift operator, and I have a number called 2. When I did a left shift operation by one position, I shifted the bits to the left by one position. In that case, it made my number to 4. Basically, it increased my power of 2 by 2. Um, and when I did right shift, it divided by 2. That's why I got 1. So that is all about the bitwise operators. Mostly that you'll be using during the examples until you, as I said, until you are really developing a big product. These operators, not using these operators will not do much harm to your overall product or the logic. However, if you're working at a small scale level, then if you don't even use them, that is totally okay. But yes, you should know about them. Now let's go and see the next set of operators called assignment operators. So here are the assignment operators. Assignment operators, as the name says, their task is to perform some operation and assign back to the variable to the left hand side or to the operand to the left hand side. So we have this list, and in fact the list, the equal to sign, equal to operator, when combined with multiple other operators, this all forms the assignment operator sets. So this equal to, you already are familiar. Whenever you use equal to sign, then in that case, what happens? The value that you have on the right side gets assigned to the variable to the left side. That's called equal to operator. Now this is equivalent to add and assign. Like you see here. What am I doing here? I'm saying, look, whatever you have the current value of var, to that you add 10 and then again overwrite var current value. For example, it is equivalent to this operation. Instead of writing var equal to var plus 10, you know what this will do? From line number 1, var is 5. So on 5, I'm adding 10. So var, now 5 plus 10 is 15. But my var is still 5. So if I have to override my var content, I have to assign it back, which I'm doing here. So now at the end of line number 3 execution, var will be 15, as you see. But the same code, which I have written with the alone assignment operator and arithmetic plus sign, I can combine them together with an plus equal to operator. This is same as saying this. So I'm saying, look, to the current value of var, assign a value of 10, then the result what you get, you override to var. Correct? So at the line, after line 5, you will have var equal to 25. So similar way, here I'm saying, to the current, from the current value of var, subtract 10, and then whatever is the result, assign it back to var. So 25 minus 10 will be 15. So you see 15. Then 15 into 3 will be 45. That's why you say 45. Then 45 modulo 6 will give you 3. A remainder will be 3. So that's why you see. Because 6 into 7 is 42. The remainder is 3. So that's why you see 3. And when you divide 3 by 5, integer division, this is, that should give you 0. 0 point something, which is 0. That's why you see 0. Is that clear? So what is the advantages of using assignment operators? Can I not use arithmetic operators? You can, up to you. But the problem is it's kind of looks redundant. You are repeating your code twice, but that at the same time, assignment operators helps you to write to basically reduce your line of code, avoid redundancy, and at the same time, it's computationally a little faster, right? So it's up to you. Let's see the next set of operators. That's called identity operators, very unique to Python. So all other operators so far we saw, you may have seen in other languages as well. But when it comes to identity operator, that's there only in Python. Identity operators, there are two operators which comes under it called is operator and is not operator. Again, these two are keywords. Okay, they have predefined meaning and you cannot change their meaning within Python context. Now, what is the use of identity operators? So identity operators are used to validate or to check if two objects have same memory address. So comparison operator tells you about their value if they share same value, but identity operators checks or compares their memory address. In Python, every object has to be stored at some memory number, and every memory has some unique number. So if you want to check any two variables points to the same memory address or not, for any reason, of course we need those sort of features or functionality to handle big situations in big product. But so whenever you have to do that, you can do it using identity operator. Identity operator is returns a boolean true when addresses of the elements are same. Otherwise it returns false. Is not works opposite of that is. It returns false when the addresses are same. So up to you which one you want to use, but we have two of them. Now let's take an example. Well, there are a lot of things that may come up here that will confuse you. So to keep this simple for you first, let's take with this example that I have highlighted. Let me tell you what's happening here. This is called a list. Okay, we are going to talk about list in the future videos, but for time being, just understand this list. List is just a terminology that represents a set of the numbers enclosed within a square bracket, and each of the numbers separated by comma, as you see here. So now to this variable or identifier, L1, I'm storing this list value. Then there is another list that I'm creating, and to this list I'm assigning L1 content. I'm copying from L1. Then there's an L3. To that also I'm copying from L1, but something extra I did. There is a method called copy method I called. So now what happened? Let's see the content of it. And okay, there's a function called id in Python that tells you the memory, that displays the memory address for any object in case if you're interested. Okay, and then I am doing some comparison operators between them. So here I'm saying is L1 equal to L2, and here I'm saying is L1 is L2. Okay, that's two different statements. Here I'm saying do L1 and L2 have same value, and here I'm saying do L1 and L2 share same memory address. Okay, so what do you think? Is that true? What value are you expecting here in terms of Boolean values? True or false? Okay, let's say line number 8. I call it true. It will give me true. And line number 9, that will also give you true. But look here. I'm now comparing L1 with L3. Remember, L2 and L3 both are a copy version of L1. I have created them from L1. But I am saying now, is L1 having same value as L3? I'm saying true, it is. But is L1 sharing the same memory as L3? And the answer is false. Let's start. So here are the results. Firstly, I'm printing L1, L2, L3. You see, you get the same values for L1, L2, L3. They have same values, no doubt, right? If you want to see their memory address, again, this can change from computer to computer, different run to different run. Do not rely. For time being, if you see L1 and L2, they have same memory address. Do you see that? But when it comes to L1 and L3, that's different. That's the reason. Here, value-wise, L1 has same value as L2, L1 has same value as L3. That's why you see true and true. But when it comes to memory, L1 has same memory as L2. That's why it's true. But L1 has a different memory than L3. That's why you have a false. Just to give you an example, okay? So that's how. So here, what you should focus on, there are a lot of information. I would say do not get confused. Right now, just focus on how does each operator works. So whenever two variables, will have same memory. Each operator will give you a true value. Whenever they will have different memory, you will get a different value. That's all you have to understand at this point of time. Rest extra background that I set for you, discard them. We will go through them in detail later videos for sure. Um, I want the response from you. There's a bonus question as well as what to think about it, and maybe you can do your self study. Um, what I'm going to do is I am going to okay here in this exercise. Let's quickly see the answer and then I will ask you the question. Um, I think this makes sense. Do you agree? What did I do? So to a variable called var, I assigned a value of 40 first, then I have displayed its memory, and the memory is something like this. Do not go behind the number. Just see something like this you have, which is certainly not equal to the second memory being allocated when I assigned a value of 45 to var. Okay? Now, I'll do one more thing. But now, if you see, when I assign the same value to var twice, both the time it has same memory, which makes sense. I think it's making sense, right? But so I'm just which is as expected, no question here. Do you agree with this result? You have 3 is 6, which is false. I mean, the memory of 3 will be something different. If you are storing both of them in the same place, they will overwrite. Then they will not be distinct anymore, which makes sense. Because, and remember, 3, 4, whatever you see green in color, they are keywords. They have predefined meaning. You cannot expect it to change based on your imagination. So is 3 not 6, which makes sense. Again, they don't have same memory. Okay, so here is a question for you. A equal to 4, A equal to B, print ID of A, comma ID of B, and also you print A equal to B, and also print A is B. What output are you expecting here? True for both of them or false? There are two different variables. My mistake. Here is a correction. I have assigned a value of 4 to A. Then I assigned that same thing I copied to B. What do you expect? Will they have same memory? Will they share same memory? And of course, they have same value. You can make out because you're copying the same thing. So here's for sure you'll get true. I don't deny it. But what about this point? I want answer from you. You can put it in the comment box. What did you get? And then we can maybe discuss if required. I have another question for you. This is 4.8. Now, what are you expecting in this? Of course, I'm expecting this to be true as usual, but what about this? Do you want to see the answer? I can show you, but you have to find out the reason behind it that I'm leaving up to you. I have one more question for you. There it goes. So A equal to 4, B equal to 4, and the rest all I copy from here. Okay, let's do that. This is saying false. Can you see? A is B false. Now, I just make it 4. There it was a floating point. This is in. Here it says true. And this is very interesting. You have to do little research, and trust me, you will get a lot of information. These are very, very important and then tricking features of Python. Again, not mandatory for you to know in order to proceed with the further videos. But if you're curious, like I am right this at this point of time, can you answer why in this case where I have two integers to the two variables, I assign same integers, and when I check their uh, address is saying true. Okay, fine. Since you can give the argument they have same value, so okay, makes sense. But why did not that happen for floating point number? They A and B here, both of them are sharing same floating point value, but the address allocated to them, that's totally different. It's not same. Why so? So that's the question, and I leave that up to you. You can write your answer in the comment box, and I'll let you know the if your answer is good, I'm certainly going to let you know so you don't wonder if and if your answer has some correction required, I will share with you the detailed explanation about it. Awesome. Let's quickly jump to the last set of operators that Python has, and that's called membership operators. Very interesting operators, very useful operators, and very powerful operators. The membership operators has two operators in each called in and not in. Okay, in case if you're not aware, in and not in, both of them are keyword. And then so membership operators are used to validate or to check rather to compare if operand 1 is a part of operand 2. Let me write it. Membership operators also takes two operand at any point of time. So it checks if operand 1, if I write like operand 1 in operand 2, so in that case it will check if operand 1 is a member, as the name suggests, membership. So it checks if operand 1 is a member of operand 2. That's always the question going to form around membership operator. And then how does it answer? So if operand 1 is a member of operand 2, it will return you boolean true, else it will return you false. It's that simple. Now the question can be, so what are the valid value that operand 1 can take and operand 2 can take? So here is the answer to the question. In Python, the operand 1 has to be something, your basic data types like int, float, string, bool. But operand 2 has to be an iterable object. Let me repeat that. Operand 2 has to be something called iterable. What is an iterable? We will get familiar with this term again in future in much detail. But just for an example, let me tell you, in Python, strings are iterable, list is iterable, tuple is iterable, and there are some more like set, these are iterable objects. So you have to make sure whenever you write something operand 1 in operand 2, your operand 2 has to be an iterable type. You can Google and read about it. How are the properties of this iterables different? I leave that up to you, but you have to know that. Now, let's take a simple example. So I have a word, word is nothing but a string, and I want to check if it has character 1p and second character p. How these characters are different? So second character is a uppercase p, first character is a lowercase p. How can I check that? Very simple. I can say character 1 in word. Now, what will this return to me? That can be a question. Well, I say this will return me true and this will return me false. Do you agree? By the definition of this membership operators, this will return you true and this will return you false. If you're wondering why false, go and watch the previous videos. That should answer you. But others should already be knowing the reason. The reason is character 2 is uppercase. Oh, my mistake. Let's swap that. Yes. So character 2. So in my word Python, P is in uppercase. So that's why lowercase p will give me false and uppercase P will give me true. Make sense? Yes. Python is case sensitive. You have to, the uppercase and lowercase characters are treated or considered different. Let's see the next example where you have a sentence and you want to see if a word is a part of a sentence. In the previous case, we checked if a character is a part of a word. In this case, I'm checking if a word is a part of a sentence. How can I check that? Very simple. A word in sentence. Word not in sentence. Word. Um, okay, that's all. You know, in and not in, they are complementary to each other or contradictory to each other. Wherever in will say true, not in will say false. Okay. So now the question here is word in sentence, is easy a part of the sentence? Python is easy to learn programming language. And the answer is for is operator true, for not is operator just opposite of that, it's easier to guess. That right? But have a look quickly. If I just make capital letter E and again ask the question, it will change because it's a case sensitive and case makes a difference. You have to be careful to work with the case. Now, let's see another third example to understand the application of this membership operators. Let's say if you have a list of the city, like no, your Bangalore, Goa, Chennai, Mumbai, Delhi, and you want to check if a particular city is a part of the list, maybe. Okay, so maybe this list can represent a group of the cities qualified for some award, and you want to check a particular city is a part of this selection. You can do that very easy way. All you have to do is present basically, which is Goa. So I'm saying is Goa in city list. So what will be the answer? Can you tell me that? It should certainly be true because Goa is a part of the city list. And that's what I got it. Of course, you can put it around the print statement. That's fine. If you say not in, that should give me false as expected. So that's it. So in and not in are very membership operators. We are going to see a lot more examples with membership operator in future. In fact, instead of studying standalone, we are going to learn it, use it, and build an application. Some small programs we are going to write with this. Hopefully, you are clear with the list of the operators that we checked in Python right now. Just practice through this example problems. I'm going to share this material via WordPress website called Upskill Space. Please look, check out over there for this materials. And if you have any questions, any doubt, feel free to ping in the comment box. I will personally have a look to them and answer you or give you a materials if that would be relevant to your question. So till then, I come up with the next video sequence. You have a happy learning.